Okay, let's have a look at some of these successive forces. Down there I said it was the bananas, and there's other fruit trees in there. And then we have fruit trees along this row as well. In the middle we have this double row of banana grass. So this is a hybrid version of elephant grass. Elephant grass tends to, flower a lot more. It's thinner, whereas the banana grass, which is from Bajra Napier hybrid, which means it's a cross between pearl millet and elephant grass. I don't know if it's really sterile, but it doesn't flower much, because they do make, if you wanted to, you can make your own banana grass. You just need to get some pearl millets and some elephant grass, and a bit of work and some patience, and they're breeding new ones every year. Sometimes they breed them just for the ornamental trade, like there's purple ones and everything. Anyway, so I've planted the banana grass all along here. That side, this side, this is about its third cut. And what I've been doing is cutting the grass. First time I've cut it and fed it to itself. Second time I've cut it and put it over there. Or in this case, cut it here and laid it, along these tree rows. What I'm trying to do is get to that magic point where these rows can completely mulch themselves and the row next to them. And when I achieve that milestone, I really start to get into very, very enviable territory. It means I no longer need to put any major inputs, external inputs into here. All I have to do is just, manage for micronutrient deficiencies, which may or may not occur, we just don't know. But in terms of the carbon inputs, it'll be self-sustaining. And the thing about, say, carbon, the relationship between carbon and nitrogen, is that we're swimming. We're in an atmosphere of nitrogen. But it takes a lot of energy to convert this atmospheric nitrogen into something plants can use. And it's carbon-based energy. So it's either going to be done by a living plant, for example, a legume. So we do put some legume plants in here. Or it can be done by non-legume nitrogen fixers. We'll talk about that one day. Or free living organisms, mostly anaerobic, and they tend to live in the root zone. Sometimes they live inside the tissues of the plants, and they will use the sugars from the plant. So you need a plant that is, producing lots of biomass like this banana grass to feed the soil, and then all the microbes in the soil, of which they're uncountable, and we have no idea about the total level of biodiversity in just regular healthy soils, because we can't culture them. It's only through genetic science that we've managed to actually just see just how many there are, or at least a window into it. And that's because we can sequence the DNA, and we see that there's so many. So we want the soil to be covered all the time. So that's going to be covered by, first of all, by this couch. And then it's going to move on, as with the spear grass as well. This is the grass that was here originally. And then I have planted the banana grass. And then we've also seen that as conditions have improved, this road grass has come up. And so I don't pull it out. I don't want it to be here long term. But I let it grow until it gets to about this stage. And I'll come in and cut this grass with a sickle. And I'll lay it down around the banana grass. So I'm feeding the lower succession plant to the higher succession plant. And that causes, this increase in life. Just keeps on, as they say, spiraling upwards. So accumulation of energy. So the other day, I think I pointed this area out, and I've done a little bit of work since. So this was, solid couch. That was solid couch, and with the sorghum in between. What I did is I just sat down on the ground with the sickle, cut my way through the couch, also cutting the sorghum, but not so low, laying the sorghum alongside where the fruit trees are. For example, we've got a macuna bean, got a white sapote there, got a jackfruit here. Now the reason I have these two really close together is I'm hedging my bets. I don't know if the jackfruit can live here. Might be too cold. I know the white sapote can, but it's just a seedling. So if the jackfruit ends up thriving, I'll just cut this for mulch. And I think these are quite vigorous, once they get going. So I can cut this tree here to feed to this tree, but if this tree dies, then I have this tree as backup. And then what I'll do is I'll graft that tree with a known variety. And then, so over here, what do we got? So, cut the cooch, lay the cooch down, and then we've got this regrowth here of this sorghum. And what I'm going to do is I might have to wait till the next cycle now, because we're getting to the point now. We're almost there, almost there. I think 1 or 2 more cuts and we'll be to the point where this whole area is self-mulching. And then you'll really start to see the magic. It's basically when the soil remains permanently covered, you know, the soil starts to turn from hard and compacted, you know, into this. I didn't dig this. I've never dug this soil. The only time I've ever dug anything is just to plant a tree. But this soil here had no cultivation ever. And let's focus in a bit more. That's just from the biological processes of a thick layer of mulch, a thick and permanent layer of mulch on top. So we keep the soil covered. We keep on, you know, growing more and more biomass to put on top. Make sure it stays nice and thick and covered. And they're also moving up this spiral succession. So we're moving from low succession plants, like the cooch that was here, up through the Rhodes grass, up into the banner grass, up into the guinea grass, and also along the tree rows. You know, we're starting off with things like mulberries, eucalyptus, and then we're moving into rainforest pioneers, and then we're moving into fruit trees, and then moving into nut trees. So there's a nut tree. It's a good example here, actually. Ah, here we go. It's a walnut tree. I just went and bought some walnuts. I put them in the fridge for, I think I've soaked them, put them in the fridge for 3 months, and then I just went and planted them around, and that's come up. It's a walnut tree. So I think that'll pretty much just sit there and won't do too much. It'll let these other plants, the mucuna, the guinea grass, the eucalyptus, they'll you know, for the first few years they'll take the scene, and the walnut will just be slowly coming up behind, but eventually it'll take over. So yeah, I think there's a lot of other things going on here, but that's the main thing. Once we get to that point where it's self-mulching, and I don't need to have inputs here, it just starts to, everything has a positive feedback, it starts to build on itself. So you've got the grass is mulching everything, that's making the other trees grow. You've got these eucalyptus, you know, they're going to end up being, say, 5 meters tall, and cut them off at 3 meters, and they're going to keep on sprouting and giving us the mulch. We're going to start to feed the soil, to build it up, so that, you know, you saw before that that soil that was really hard is now soft. I can dig down with my fingers to plant, you know, about that far. And what we're hoping is that, you know, you keep on putting the mulch on top, and then that soil will darken and deepen, and we'll keep on going even further down. Later on, we might do a bit of broad forking just to help out. But yeah, mostly going to be biological processes. All right, well, next time I'll probably go and have a look at these gardens over here. These are much younger, so say 8 months younger than these, so still in a much earlier stage, but they are lucky to have a few fruit trees that have been established there for a while. So next time we'll go have a look at those. So yeah, thank you very much. Check you later.